You feel the heavy, numbing cold of the refrigerator door as you pull it open. The condensation on the glass bottle is slick, a biting chill that transfers instantly to your fingertips and palms. As you pour that thick, white liquid into a glass, the smell is faint, earthy, slightly sweet, and utterly familiar. But as you take that first sip, have you ever stopped to wonder why that liquid came from a cow? Out of more than 5,400 species of mammals on this planet, why is it that your cereal, your coffee, and your cheese are almost exclusively powered by the secretions of a single species of bovine? Why don't we drink the milk of a pig, which lives in close proximity to us? Why don't we harvest the nutrient-dense milk of a deer, or the high-fat milk of a seal, or even the biologically compatible milk of a donkey? What made the cow the undisputed queen of the dairy aisle while nearly every other mammal was left out in the cold? This leads to a biological puzzle. To understand why we don't drink other milks, we first have to ask, what exactly is milk, and why is it so different across the animal kingdom? We tend to think of milk as a generic substance, a white liquid that provides calcium and protein, but to a biologist, milk is a highly specialized survival kit. It is a biological fluid calibrated by millions of years of evolution to meet the hyperspecific needs of a newborn. If you look at the composition of different milks, you start to see why some are perfect for humans and others are practically toxic. Take the hooded seal, for example. A seal pup needs to grow a thick layer of blubber almost instantly to survive the freezing Arctic waters. Because of this, seal milk is roughly 60% fat. If a human were to drink a glass of seal milk, it would have the consistency of heavy cream or soft butter, and the sheer caloric density would likely send your digestive system into a state of shock. On the opposite end of the spectrum, you have the black rhinoceros. Rhino milk is incredibly low in fat, sometimes as low as 0.2%, but very high in lactose. Every species has its own white gold, designed for a specific growth rate and a specific environment. So, if every animal has a custom-made recipe, why did we settle on the cow? Is there something inherently superior about bovine milk, or were we just lucky that cows happened to be in the right place at the right time? The answer begins with a genetic miracle that happened 10,000 years ago. For most of human history, the idea of an adult drinking milk was not just strange, it was physically painful. Mammals are biologically programmed to drink milk only during infancy. Once a young animal is weaned, the body stops producing lactase, the enzyme required to break down lactose, which is the primary sugar in milk. Without lactase, drinking milk as an adult leads to bloating, cramps, and severe gastrointestinal distress. This was the human standard for hundreds of thousands of years. But around 8,000 to 10,000 years ago, something changed in the DNA of a few small populations in the Balkans and Central Europe. A study published in 2007 by researchers like Joachim Berger at the University of Mainz analyzed the skeletons of Neolithic farmers and found that they lacked the gene for lactase persistence. They were keeping cattle, but they weren't drinking the milk fresh. They were likely fermenting it into cheese and yogurt to lower the lactose content. But then, a single point mutation occurred, the T13910 allele. This mutation kept the lactase enzyme switched on for life. Why did this happen? And why did it happen with cows and not the hundreds of other animals these early humans encountered? This brings us to the logic of scale. When you look at the economics of milk, you realize that not all udders are created equal. If you want to feed a growing civilization, you need an animal that can produce a massive surplus of milk beyond what its offspring needs. A modern Holstein Friesian cow can produce upwards of 10,000 liters of milk in a single year. Compare that to a sheep, which might give you 200 liters, or a goat, which might give you 600. To get the same amount of milk from sheep that you get from one cow, you would need to manage, feed, and milk 50 different animals. That is a logistical nightmare. But what about the pig? Pigs were domesticated early, they are prolific breeders, and they are everywhere. Why isn't pig milk a thing? The answer is a mix of biology and temperament. A pig has 14 teats, not 4, and they are notoriously difficult to milk. Unlike a cow, which has a large cistern or storage area in its udder that allows the milk to be withdrawn easily, a pig only releases milk in response to the specific oxytocin surge triggered by its piglets. They are also incredibly aggressive when nursing. If you try to milk a sow, you aren't just dealing with a difficult animal, you are dealing with several hundred pounds of muscle and teeth that does not want to be touched. But if pigs are too aggressive, what about the more docile animals, like the horse or the donkey? The numbers tell a different story. There is a long history of humans drinking equid milk, the milk of horses and donkeys. In fact, if you were to look for a milk that is biologically closest to human breast milk, you wouldn't go to a cow, you would go to a donkey. Donkey milk is remarkably high in lysozyme, an antimicrobial enzyme, and has a protein profile that looks much more like ours than a cow's does. In the 19th century, donkey milk was actually used in French hospitals and orphanages to feed infants who couldn't be breastfed because it was so much easier on their digestive systems. Even earlier, in ancient Rome, it was prized as a luxury health tonic. So why don't we see donkey milk in every supermarket? It comes down to yield and the cost of the animal. A donkey produces very little milk, often less than 2 liters a day, and unlike a cow, a donkey will only produce milk if its foal is standing right next to it. If you take the foal away, the milk dries up. This makes large-scale industrial production nearly impossible. This leads to an even stranger question. If we couldn't scale up donkeys or pigs, why didn't we choose the animals that were already built for the cold and the mountains, like the moose or the reindeer? Geography changed everything. In the high latitudes of the north, reindeer milk was once a staple for groups like the Sami people of Scandinavia. Reindeer milk is extraordinarily rich, containing 22% fat and 10% protein. It is so thick it's almost like a paste. But reindeer are not grazers in the way cows are. They are migratory animals that require vast ranges of land. You can't put 1,000 reindeer in a barn and expect them to stay healthy. There have even been attempts to domesticate moose for milk. In Russia, the Kostroma moose farm has been experimenting with this for decades. Moose milk has high levels of lysozyme and is used in local sanatoriums to treat gastrointestinal diseases. But moose are solitary, high-stress animals. If they get spooked, their milk production shuts down instantly. They are also incredibly picky eaters, requiring a complex diet of willow bark and aquatic plants that makes them expensive to keep. Cattle, by contrast, are the perfect middle-of-the-road animal. They are social, they are relatively easy to herd, and they can thrive on a simple diet of grass, a resource humans can't eat, but cows can turn into high-calorie, white gold. But even if cows are the most efficient, how did they become the global default in places where they weren't even native? History left us with a choice. The dominance of cow's milk isn't just a result of biology, it's a result of colonialism and power. When European powers expanded across the globe in the 15th through 19th centuries, they didn't just bring their languages and their laws, they brought their biology. They brought the cow culture of Northern Europe to the Americas, Australia, and parts of Asia and Africa. In many of these places, the local populations were 100% lactose intolerant. In East Asia, for example, dairy was historically seen as a strange, even repulsive, dietary habit. But the European cattle-based agricultural system was so productive and so tied to the economic structures of the time that it began to overwrite local food traditions. Even in places with their own dairy animals, like the water buffalo in India or the camel in the Middle East, the industrial infrastructure built during the colonial era was designed for the cow. Today, the water buffalo is actually the second largest source of milk in the world, providing about 13% of the global supply, mostly in India and Pakistan. Buffalo milk is higher in fat and solids than cow milk, which is why it makes such incredible mozzarella and ghee. But in the global trade market, the standard is always the cow. This raises a deeper question. If we are so tied to the cow, what happens when the environment changes? The environment dictates the limits of our diet. As the world gets hotter and water becomes more scarce, the cow's throne is starting to look shaky. Cattle are water-hungry animals. It takes thousands of gallons of water to produce just 1 gallon of milk when you factor in the crops needed to feed the cow. This is where the camel enters the conversation. Camel milk has been a survival staple for nomadic cultures in the Middle East and the Horn of Africa for millennia. Unlike cows, camels don't need much water to produce milk, and their milk doesn't spoil as quickly in high heat. It's also packed with 3 times more vitamin C than cow's milk and contains insulin-like proteins that are being studied for their effects on diabetes. In 2020, researchers at King Saud University pointed out that as desertification increases, the camel might be the only viable dairy animal left in certain regions. We don't drink camel milk because of a historical fluke of geography. European explorers didn't use camels, so the global infrastructure was never built for them. But if we lived in a world where the Sahara was the center of global trade, your morning latte would be made with camel milk, and cow's milk would be the expensive, exotic rarity. But there is a darker limit to our milk choices that we rarely talk about. Ethical and biological barriers prevent a milk everything world. There are animals we would never dream of milking, not because it's hard, but because it feels wrong. Take the primates. We are primates, and our milk is specifically designed for the slow, brain-heavy development of a human infant. But could we milk other primates? Technically, yes. But the yield would be tiny, and the ethical implications would be monstrous. Then there are the carnivores. Why don't we drink dog milk or cat milk? Beyond the obvious gross-out factor, there is a fundamental rule in ecology called the 10% rule. It takes 10 pounds of plants to make 1 pound of herbivore, and it would take 10 pounds of herbivore to make 1 pound of carnivore. Keeping a lion for its milk would be an energetic disaster. You would have to feed the lion vast amounts of meat just to get a tiny amount of milk back. It is far more efficient to skip the middleman and milk the animal that eats the grass directly. But this efficiency comes at a cost. By focusing so heavily on the cow, we have created a biological monoculture. We have bred the Holstein cow to such an extreme that it is essentially a biological milk machine, often at the expense of the animal's health and the diversity of our own nutrition. Are we missing out on something by ignoring the wild milks of the world? Complexity is hidden in the shadows of the dairy aisle. When you look at the milk of a kangaroo, the complexity is staggering. A mother kangaroo can produce 2 different types of milk at the same time from different teats, one for a newborn joey and one for an older sibling. The chemical composition changes as the joey grows, shifting from high sugar to high fat. We could never replicate that in a factory. Or look at the platypus. The platypus doesn't even have teats. It sweats milk onto its skin for its young to lap up. This milk contains unique antibacterial proteins that could hold the key to fighting superbugs. We don't drink these milks because they are too complex, too weird, and too difficult to harvest. We chose the cow because the cow was simple. It was a 4-legged tank that turned grass into a predictable, standardized product. But that standardization has made us forget that milk is alive. It is a communication system between a mother and her offspring. When we drink the milk of another animal, we are intercepting a biological message that wasn't meant for us. And as we've seen, that message can actually change who we are. Our bodies are the living proof of this ancient relationship. This brings us to the ultimate reveal. The reason we drink cow's milk is not just that we domesticated the cow, but that the cow domesticated us. Evolution is usually a slow, agonizing process that takes millions of years, but the ability to digest milk is one of the fastest and most dramatic examples of natural selection in human history. In a few hundred generations, we went from a species that would get sick from a glass of milk to a species that built an entire global civilization around it. In parts of northern Europe, the lactase persistence gene is found in more than 90% of the population. This wasn't a random accident. During times of famine or crop failure, the people who could drink fresh milk survived, and those who couldn't died out. The cow provided a liquid bridge that allowed humans to survive in environments that would otherwise have been uninhabitable. We are mutants who have successfully hijacked the reproductive cycle of another species to fuel our own expansion. But this leads to a final, uncomfortable question. What happens if the bridge breaks? The future of milk might not be animal at all. We are currently living through the greatest shift in dairy history since that first mutation 10,000 years ago. For the first time, we are moving away from animal milk entirely. Almond, soy, oat, and pea milks are taking over the shelves. But even more radical is the rise of precision fermentation. Companies are now using yeast and fungi to brew real dairy proteins, whey and casein, without a cow ever being involved. They are taking the DNA instructions from a cow and inserting them into microbes to create a liquid that is molecularly identical to milk but requires no animal and a fraction of the land and water. If this succeeds, the 10,000-year reign of the cow might finally come to an end. We will have successfully decoded the white gold and separated the product from the producer. But will it feel the same? Will a glass of yeast milk carry the same weight as the substance that literally rewrote our ancestors' DNA? Or are we just entering a new phase of our long, strange history of drinking things we were never meant to? The logic of our history is written in the liquids we consume. We drink cow's milk because it was the most efficient way to survive a harsh world. We don't drink the milk of pigs because they're too mean, donkeys because they're too stingy, and lions because they're too dangerous. We are a species of opportunists who found a biological loophole and exploited it to the maximum. But as you look at that glass of milk, remember that it isn't just a drink. It's a record of a struggle. It's a record of a mutation. It's a record of a time when the difference between life and death was the ability to digest a single molecule of sugar. We have spent 10 millennia turning the cow into a servant of our biology, but in doing so, we tied our fate to hers. The dominance of cow's milk is a testament to our ingenuity, our ruthlessness, and our incredible ability to adapt to the tools we have at hand. But it's also a reminder of how narrow our perspective has become. In a world of 5,000 milks, we have focused on one, and we've called it the standard. This brings us back to that biting chill in your hand. Think about the sheer impossibility of what you're holding. You are an adult primate, an animal that should biologically be incapable of processing dairy, yet you are drinking the milk of a large, hoofed herbivore that was bred over thousands of years to be your perfect nutritional mash. Every time you pour a glass, you are participating in an ancient biological heist. You are the beneficiary of a genetic fluke and a series of historical accidents that began in a small village in the Balkans 10,000 years ago. We don't drink other animals' milk because we don't need to. The cow did everything we asked of her. She grew our children, she fueled our empires, and she changed our very DNA. But as the climate shifts and technology advances, we might find that the age of the bovine was just a brief chapter in a much longer story. What do you think? If you could try any animal's milk, knowing it was perfectly safe, would you reach for the high-fat cream of a reindeer or the vitamin-rich milk of a camel? Or does the very idea of drinking a wild milk make you realize how deeply the cow has influenced your sense of what is normal food? The more we look at the history of what we eat, the more we realize that our defaults are often the strangest things of all. If this deep dive into the hidden history of our diet surprised you, consider subscribing. We spend our lives surrounded by things we take for granted, but as we've seen today, even a simple glass of milk is a mystery 10,000 years in the making. But there is one final detail that should stay with you. Remember the T13910 mutation? That tiny change in a single gene that allows you to drink milk today? If that one single letter of your DNA hadn't flipped from AC to AT in a handful of prehistoric farmers, your entire world would look different. There would be no sprawling dairy farms, no mountains of cheese, no milk-based economies, and quite possibly, your ancestors wouldn't have survived the winters that led to you. That glass in your hand isn't just food. It is the only reason you are here to hold it. The cold glass against your palm is the weight of a 10,000-year-old biological debt, a haunting proof that we didn't just domesticate the cow, she rebuilt us in her image, one drop of white gold at a time.